into an empty vase at a constant rate, That means the water, imagine you turn on the faucet and water just keep going in, okay? The graph not shown models the depth of water in the vase over time. So the graph represents the height of water or the depth of the water. The graph can be described as follows. The graph is always increasing. That means your function is always going to go up. Now, that's understandable because when you pour water into a vase, the height of the water is always going to keep going up. You guys see that? Because it's not leaking out, right? So it's always going to go up. The first portion of the graph is clearly concave up. And then the next portion of the graph is fairly steady with a steep increase. So we're going to make a little sketch so we can see what's going on. Yeah? So it says that the first portion of the graph is concave up. And we know it's increasing, so it's got to look like this. Okay? It's concave up and increasing. Like that. That's the first portion. The next portion, they tells me, is that the graph is fairly steady with a steep increase. Steady means it's a line. Steep increase means the slope is a big number. Is that good? So I'm going to say it might look like this. That's my line. So that's what my graph could look like. Okay? So now, based on that, you're going to have to make sure you understand, well, what does this mean? Well, this stands for the depth of water. This stands for time. Okay? So now, based on this, I can see that at the very beginning, the depth of the water increased slowly. You guys see that? So what kind of vase should I have? What kind of shape should I have at the very beginning so that the height of the water go up very slowly? It has to be very wide. Is that good? Because if the bottom is wide, then you need more water to fill it up. Do you guys see that? So the height of the water or the depth of the water is going to go up very slowly at the beginning. So I'm going to say the bottom, right, have to be wide. So it have to be wide on the bottom. Okay? And then as time go by, the depth of the waters go up. Now it's go up a little bit faster here. What kind of shape of a vase could be so that from increasing the height at a lower pace, now it's go up to a faster pace. Narrower. So that means after the bottom is wider, as it go up, it need to go narrower. Do you guys see that? Because narrow mean, hey, the water will fill up faster. You guys good? Now what happened right here? Do you guys see that as time go by, right, the water go up faster and faster? You guys see that? Now, what is a scenario where the water, that can cause the water to go up really fast? When the top is very narrow. Do you guys see that? Because if the top is narrow, that means it's going to fill up the water faster compared to the one at the bottom. You guys see that? So what you're looking at is a situation where you have that kind of vase. So you can see that D and C are out because the bottom of the vase is not wide, it's narrow. So that means at the beginning, the water is going to go up very fast. So C and D are out. Okay? Here, the bottom is Y, so is B. But notice if you look at the very top, you see that the top is also Y as well. And that means the water, as it gets close to the end, is going to slow down. The depth of the water is going to slow down. You guys see that? So it's going to decrease at a slowest pace. Here's your answer. So at the beginning, the depth of the water go up very slowly. But as it go up, notice because the bottle is narrower, the height of the water is going to go up faster. So your answer should be B. All right? Anything else that you need help?